Thanks for watching Modernizing Missile Defense, presented by Carasoft and MFGS Inc., master supplier for micro-focus software. I'm your host, Francis Rose, with the Government Matters Thought Leadership Network. In this special program, we'll cover digital transformation efforts in the missile defense arena, the cybersecurity measures that need to be built into these systems, plus how decision makers are meeting the ever-changing threat landscape. Joining me first, Laura DeSimone, Executive Director at the Missile Defense Agency, and Bryan White, Cybersecurity Specialist at MFGS Inc. Welcome to both of you. Thanks for coming on the program. Laura, I start with you. What are your big agenda items right now at MDA?
Thanks for the question, Francis. At the Missile Defense Agency, with our mission to develop and deploy capabilities to defend the United States against missile attack, we're always focused on what the adversary is doing. So right now our focus is on developing a new space-based sensor that'll help us with tracking missile from their birth or launch all the way through to where we can intercept them. So that's one of our focuses. Another focus is a new program called the Next Generation Interceptor. As you know, we have over 40 interceptors that are protecting the United States right now, ground-based interceptors that are up in Alaska and California. Those missiles right now can defend the United States against the current threat, but in the future, we know we need a more capable system. So we just let 2 contracts with industry teams to help us get after that next generation interceptor.
Is the new interceptor technology necessary because our adversaries are changing their capabilities, evolving their capabilities, or because we're developing technologies that are more capable than what we already have, or some combination of both?
It's exactly a combination. As you know, our adversaries know what systems we have today. So it's a little bit of a cat and mouse game. So they are testing right now new capabilities that will try to fool our systems. So we call a lot of these countermeasures. So in these long-range intercontinental ballistic missiles that fly through, most of their flight is in outer space. While they're flying, they'll deploy countermeasures to try to fool our systems. So it's important for us to be able to have capabilities to discriminate in outer space to help us consummate that interception and take out these reentry vehicles. Also, industry has come a long way with advancing new technologies that'll help us with those discrimination capabilities. So we want to bring the best that industry has, to our warfighting capabilities.
Bryan, welcome. Thanks for joining the program. What are the security implications for this evolution, for this cat and mouse that Laura described?
Yeah. Thanks, Francis, for having me on. So she's talking about layered defenses, and I'm not going to go into the kinetic aspects of it. I'll leave that to her as the expert there. But from the cyber perspective, obviously you've got your satellite base. She's trying to do the tracking in space. So obviously that requires satellite links down to land or, say, ship-based systems. So you got your latency going from that satellite uplinks. Obviously you want to make sure that connection is not taken out. Our adversaries obviously are looking to do the same thing, not just within space sensors, but also to look at our command and control network. So what we look at is not just from the operational aspects of the, is a system online? Can I reach a sensor? Can I reach a system? But also, is that system hardened? What is the security posture? Not just the sensors in space, but also our networks where they're housed, the building, the ships where these, some of these sailors are out, in the middle of the ocean kind of monitoring because they're closest to the uplink. So again, all those aspects, obviously anything we can control within our physical boundaries is helpful. Space is another domain, obviously. The Space Force is created, but we're not out there yet actively, physically protecting those assets. So that is a concern as well, the physical, and the actual cyber components.
Bryan, does the cybersecurity requirement for a system like we're discussing here become more complex because of the complexity of the system itself, or does the cybersecurity requirement stay pretty consistent because of what the threat landscape looks like?
Well, so I'm a security guy, so honestly, if I stay consistent, I will miss my adversaries. So the one thing, though, with the missiles, like, she was mentioning is the next generation interceptor. Some of that technology, that's been out there that those are going to replace have been there for a while. So the command systems, the control networks, that may be legacy, some of the data networks, as it's being enhanced. Every government agency is looking at doing those upgrades to ensure the proper throughput. The data, the logging is, year over year it increases, right? The amount of data and the amount of logs we get to capture those systems is greater. We want that detail, but then what do we do with the data? So I look at that as obviously a good change, but it's a hard to kind of quantify over time, because you want to make sure that you can track those hypersonic weapons, but what amount of data is feeding into those sensors that we don't know about. So,
Laura, the Defense Department broadly has seen a tremendous rise in the amount of code, the software component of major weapon systems. Is that happening in the missile community also?
Absolutely. These are such complex engagements that it really does require software to help in that discrimination example that we just talked about. But the processing of data throughout the system, as Bryan talked about, is very important, and the protection of that data. So our systems are heavily dependent on software. So it's very important for us to protect the boundary layer, if you will, so those adversaries in the cybersecurity threat cannot get into our systems. So it's not only about protecting the boundary, but if in some case a cybersecurity threat got into the system, to prevent their lateral movement inside the system. So we have protections not only at the boundary, but also inside the system to try to thwart, for the software to try to thwart any cybersecurity threat.
How has that changed, Laura, the way that you think about requirements or write requirements formally for new projects?
We bake it right in, and you're exactly right. If we have to make sure from a requirements perspective, we're capturing all of the provisions and mitigations we want the system to be able to protect against. If we don't put it in the requirements right up front, then industry, it's harder for them to solve it. So it's a partnership. Not only do we, an example of the ballistic missile threat that we talked about earlier, but the intelligence community, Cyber Command, they're always looking at the cyber threat and informing us on what those threat vectors look like. We pass that information to industry in the form of requirements for our systems.
Bryan, do the techniques for writing the software that Laura's talking about apply, the same ones that apply in other types of software writing from a security perspective, DevSecOps, digital engineering, and so on? Do those same concepts apply in this sphere?
Oh, they do, obviously. I mean, so, writing applications, your programming obviously kind of aligns. It's whatever the programming language is. So a lot of the new technologies, depending on what they're utilizing, again, whatever system it's going into, the requirements really require, and I don't want to go onto the supply chain bandwagon and try to protect it there, but for the static analysis testing, you definitely want to make sure you know your code, whoever's writing it. Laura mentioned vendors. I am a vendor, so I'm guilty as charged, but we also not want to monitor our own code, but as you're writing your own, you need to be able to tune those systems and identify the requirements going into it. Is it for the risk management framework? Are you just checking a box for compliance? Or do you really know that, say, a certain application is being, configured for a specific area or region, space, versus land? Obviously, the code is going to be written differently to handle different bandwidth. So you want to kind of identify different holes. It's risk versus availability. It's that symbol CIA triad. Is it confidential? Is it available? What do you want it to be? Your integrity. So you have to kind of look at that data and figure out how you want to scan that code, make sure it's secure. So that the missile and the command and control networks can do what they need to do to keep us safe.
Bryan, you're alluding to where I wanted to go next, and that is that, for example, you are contracted to be the vendor for a particular system or a particular aspect of a system, but you're not necessarily the vendor for the entire project. What does one vendor do to make sure that the systems that their project is interacting with, that they don't necessarily have control over the code for, will mesh well, will interact well?
So that's a good question. So again, so as a software company, when we put our services on the ground, we obviously want to work closely with the system integrators that Laura's working with, has tasked to have those work statements to complete the mission. Some of it could be multiple system integrators, multiple products, different task orders. We like to, again, as a vendor, be involved in all of that, obviously, so we get the more information and be able to make the right decisions. But it can be a little difficult when we're only part of, say, module 1. We don't really know the end module 2, so what we put into it may not be full requirements, maybe partial requirements, if you will. So you want to kind of, trust the system integrators are going to take, what we put into it and have the final product, to what, Laura and team and, our end customers want and can use. So it's a very tough one, though.
Laura, you talked about that relationship with industry at the beginning of our conversation, and I want to go back to that comment. Are they bringing you technologies they think you can use, or are you inquiring to them as to capabilities that you'd like to have? Or is it some combination of those two, or is there some other process altogether?
It's absolutely a combination of the two, Francis. For the most part, I'll say in large system acquisitions, we're working with the warfighter community, the intelligence community to set the requirements for the program. So, but also industry makes investments in science and technology through multiple programs to try to advance technologies, because they also have a mission space. They understand they have the subject matter experts and what particular technology companies focus on. So no better than them to help us understand what they can bring to bear to help us. So it's a combination of setting requirements based on warfighter needs, but also understanding technologies that industry is bringing forward.
What are the most constructive ways that you could see industry, Laura, continuing that R&D work in a way that pursues what you and your colleagues need at MDA, that you will find useful?
Those investments by the department holistically in science and technology in the early research phases are critically important. I mean, we depend at MDA, I'll say, on the holistic investments that the department makes in these areas. So continuing to support science and technology is absolutely a department imperative. And industry knows this as well. So whether it's a direct investment from the department to industry or part of their what they call the IRED program, it's their internal research and development programs where they take a portion of their profits and invest them back in the marketplace, and they do this as part of those programs.
You talked about your priority list earlier, Laura. Do you have a sense what's over the horizon? Do you have a sense of where at least your capabilities requirements or requests may be a year from now, 2 years from now, 5 years out?
That's a great question. For us, all missile attacks start with a launch. So getting as much information about threat launches is really a big focus area for us. Right now, I mentioned earlier, we have this space sensor program that we're working on right now, the hypersonic and ballistic tracking sensor. So if we're able to have a constellation of sensors out there that can detect and then track throughout the trajectory these missiles, that is really a fundamental priority for us right now. We can't engage what we can't see. So although we have a pretty comprehensive network of radars, these are land-based radars strategically located in various combatant commands, really having a persistent overhead sensor that is space-based, that can watch the trajectory, the entire birth to death, is really where we want to make some heavy investments over the next couple of years.
Laura DeSimone, Bryan White, thank you very much for a great conversation. I appreciate your time today. Up next, you'll learn how defense and cyber leaders are leveraging DevSecOps and digital engineering. You're watching Modernizing Missile Defense on the Government Matters Thought Leadership Network. Stay with us.
Modernizing Missile Defense is sponsored in part by MFGS Inc. and Micro Focus Government Solutions. Learn more at mfgsinc.com. Modernizing Missile Defense is sponsored in part by Carasoft, Learn more at Carasoft.com/innovation.
Welcome back. You're watching Modernizing Missile Defense, presented by Carasoft and MFGS Inc., master supplier for micro-focus software. In the modern era, missile defense systems have to be agile and dynamic to meet threats now and in the future. Here now, Colonel Daniel Wolter, Senior Materiel Leader at the Next Generation Overhead Persistent Infrared Space Systems, part of the Space and Missile Systems Center, and David Ray, Public Sector Chief Technology Officer at Micro Focus Government Solutions. Gentlemen, welcome. Thanks very much for coming on. Colonel, I want to start with you. I read from the Space and Missile Center's website. Space and Missile Center is the center of technical excellence for developing, acquiring, fielding, and sustaining military space systems. What are your big agenda items right now?
What we do at the Space and Missile Systems Center, we have both the SBIRS mission as well as the next-gen OPIR systems. And for SBIRS, we have the launch of GO5 and 6 that are coming up over the next year and a half. And that will fill out the constellation for next-gen, or for SBIRS. On next-gen OPIR, we have satellite launches for both GEO and polar that are coming up in the next 5 years. And we have an intention to ensure that we are countering the adversaries' capabilities to hold our systems at threat, and that we have improved capability against a growing arsenal of missile warning or missile capabilities across the globe. So we've made some significant enhancements in the capability, and we are ensuring that we have the capability to counter those threats. On top of that, we have prototyping efforts that we're executing, and in the missile tracking arena, we have studies that are going on in concert with SDA and MDA in order to execute the next generation and the follow-on capability to get after the even harder threats.
What are the building blocks that got you to kind of the edge of this? It sounds to me like you're talking about being on the edge of really deploying these capabilities. What were some of the kind of the mileposts that you had to hit to get you to where you are today, Colonel?
Yeah, that's a good question. So we had, as we started the next generation OPIR program, both GEO and polar, we had we had to start very quickly in order to get on orbit in the time frame that the Joint Requirements Oversight Council had asked us to, based on the threat. And so what we did in order to start, we looked at what the technology was that was available and what the technology was that we could put together in rapid fashion. And so we have taken significant advancement in the general building blocks for overhead infrared capabilities, the space-based infrared capabilities that have taken place over the last several decades. And we were able to put those together. We have enhanced the capabilities through deliberate investment, both with our AFRL, so the Air Force Research Laboratory, as well as our own investment dollars, as well as advancements that industry has taken. And we're able to, just through market research and understanding of what's taking place within the marketplace, we were able to put together a very deliberate resiliency capability to do the foundation of missile warning capability for the nation.
Colonel, thanks for that. It's a terrific insight. David, welcome. Thanks for joining the program as well. As you look across the department, what are organizations inside the department doing well when it comes to cybersecurity and technology integration into these really high-end systems like the Colonel's talking about?
Well, first, thanks for having me on, Francis. We're actually helping support several of those mission payload development applications, both the next gen and the SIPR. And most of that work is through our channel and our partnerships within the large systems integrators that have been awarded several of those projects. And what they've done is they've flowed down a lot of those tough requirements, around resiliency to product capability that we produce, for things like network operations management, network automation, some of the blocking and tackling IT operations tools, as well as some of the security and threat modeling tools that we have that we've been using with these channel partners for years. But it's taking that to the next level and being able to use some modern techniques like AI ops, better correlation of data, and having a risk-centric model that can grow and adapt to threats dynamically. And that's some of the things that we've been focused on very tightly and working closely with our integration partners to try and help with.
You used a word there, David, that your colleagues and our guests from the Missile Defense Agency used in the first part of this program. That's resiliency. What does the word resiliency mean in the context of these kinds of high-end applications? Is it the same meaning that it has when we're thinking about an information technology network, or is there a different context in a major system like this?
Sure. Well, to me, it's always been about sustainment of mission capability, irregardless of what happens with infrastructure, IT, and other components within a system of systems. And in order to do that effectively, you really have to move towards modern architectures that are built for resilience. Cloud architectures, things that can leverage an underlying infrastructure that can scale and be elastic, as well as provide automatic failover if there is components. I also think from a security perspective, we're getting to the point where it's very difficult to monitor, to keep pace with a lot of the adversaries that are out there. And simply doing aggregation and monitoring of and risk list of applications really isn't good enough anymore. We kind of have to evolve to being able to correlate risk better, to have a central risk engine, across your infrastructure that monitors the availability of a mission capability all the way, beyond the IT and the services, but actually testing the capability to make sure it's available. And then the second piece, I think, is having redundancy built in to the support structures, not just redundancy in the components that are being provided, but actually into the business processes that are monitoring and governing, the ultimate solution. So if you need to change your attack surface or to leverage a secondary or backup facility, you can for operations and command control.
Colonel Walter, what does writing the requirements for resiliency look like? How does one know that a system is resilient or is not in order to be able to specify in a document, if you do these things, it'll be, I'm not, maybe I don't mean to put words in your mouth, but resilient enough, I guess, is one way to look at it. Or am I looking at it entirely wrong? Maybe I am.
No, it's a great question. And so as we started looking at this, we went to our intel partners, NASIC, DIA. They do regular threat assessments of adversary capabilities, it's really anyone's capabilities, any on-orbit capabilities. A threat is really a capability and the intent, right? So the intent can change at any time. So we study the capabilities that we either observe or are tracking as potential, and the transfer function of that particular threat on our space vehicle, onto our ground system, onto the links that connect the satellite to the ground system. And we ensure that we have the capability built in order to be resilient against that particular threat. And so that's how the requirements are constructed in order to ensure that we have the ability to operate through and continue operations through.
All right, David, so now we have an idea of how the customer looks at resiliency. You talked a little bit about moving toward that. How do you go about taking those requirements and incorporating things like DevSecOps, like digital engineering, some of the other concepts that provide the resilience that you talked about a few minutes ago. How do you demonstrate on the back end, we're supplying what you've asked for?
Sure. Well, a lot of the DoD components are using techniques like creating a software factory for DevSecOps and having a common repository for code and changes through the build cycle. I'd like to discuss going a little bit beyond that and providing enterprise services for those teams that are trying to secure code and secure applications. So you're basically building in security by definition. And that's moving really to a zero outage model. A lot of people talk about zero trust, especially with the software supply chain risk, but zero outage is a new technique where in industry we're working on some standards that allow you to kind of bake in a lot of the security hooks that you need in place in order to adequately monitor and then dynamically shift or change, the environment over time, so that you're not setting up your NOC and your SOC and your monitoring tools for each application. It's basically you have standards that are built in, and then it's easier to have a consistent set of metrics and services that are providing a capability that exists across an enterprise. So hopefully that answers your question. It's moving more to enterprise services. So a couple examples would be software assurance and performance testing can all be services versus each team developing their own processes for that capability.
David, the thing that I think you said there that is the most important is building these protections into these systems. This has been kind of the golden ticket that people have been seeking in the cybersecurity area for, as long as we've been aware that there's a cybersecurity area. What kind of got us over the hump? What got us to a point where we understand that and we can be confident that we're no longer having to go back and bolt stuff on?
Well, I'd like to say we're there, but I don't think we are. I think there's still a lot of work to be done. But I think security by design was the first technique. As being able to make sure we have a working, well-architected solution that is repeatable. I think getting better at standards and enterprise architecture across an organization with policies also was a big help. Moving forward to something like security by definition requires a lot of process automation and runbook automation, so that when you're deploying these systems, it's automatic. And I think that's what we're evolving to today, especially with working security into the provisioning of infrastructure and applications, which you've seen in a lot of the software factories. But I still think there's lots of room to expand on that. I don't think we're quite there with consistent standards in industry on our end, not necessarily government's end, and getting agreement between industry partners on metrics and data service models and cloud service models that can be repurposed easily by government.
David Ray, Colonel Daniel Walter, it's great to have both of you on the program. Thanks for joining me today. And thank you for watching this special program, Modernizing Missile Defense, presented by Carahsoft and MFGS Inc., master supplier for Micro Focus software. For more information on the subject matter we discussed today, go to govmatters.tv/MFGS. For the Government Matters Thought Leadership Network, I'm Francis Rose.